So here we have a Shannon and Nyquist problem, which reads, if a binary signal is sent over a 3 kHz channel whose signal to noise ratio is 20 decibels, what is the maximum achievable data rate? Calculate the same for a noiseless channel, which occupies a spectrum between 1 MHz and 7 MHz and transmits data using a using 4-level digital signals. So for now, we're just gonna go ahead and see our formulas. Nyquist, the maximum data rate equals 2h log base 2 v, and the maximum data rate will have units of bits per second. And now for Shannon, we can calculate maximum data rate with h log base 2 of 1 plus the signal to noise ratio in bits per second as well. So for this problem, we're gonna have a two-part going on. The first part is gonna be Shannon, just because the noiseless channel part is second, so I'm gonna go ahead and jump onto this afterwards. Right now, we're just gonna work on Shannon. They give us 20 decibels, which is basically the signal to noise ratio, but we need to, since it's in decibels, we need to do a small conversion before we plug into our formula. So for that, I said 20 equal to 10 log of s over n, and I go ahead and divide both sides by 10. So I would end up with 2 equals 10 over 10 is 1. 1 times log of s over n is just log s over n. I will end up with 2 log of s over n. But now I want to get rid of this log because I want to find the signal to noise ratio. In order to do that, I'm going to raise both sides to the 10th power. I'm going to have 10 raised to whatever I have on both sides. So 10 raised to the second and 10 raised to the log base 10 s over n. Take notes that this log is base 10, not to be confused with this one. So 10 raised to log 10 of s over n, 10 log 10 is going to cancel out, and this is going to come down as s over n equals 10 to the second, which our signal to noise ratio is going to be 100. And why did I highlight this? Well, these are the two pieces of information that we're going to need in order to get the data rate. So now we are going to go ahead and see how our formula looks like with everything plugged in. So MDR, maximum data rate, equals H, which is in this case our frequency, 3 kilohertz, times log base 2 of 1 plus 100, because s over n is 100. And then from there, we're just going to go ahead and solve. So this is going to be 3k times log base 2 of 101, right? And then for our purposes for the exam, our teacher told us that we don't need to find the exact number here. We just need to find a 2 raised to something so that we can just eliminate log base 2 with that 2 inside, and then the exponent, bring it down using rules, the logarithmic properties. So for that, I will just go ahead and I'm going to start guessing. So 2 to the 8th is going to be 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. So 2 to the 5th is going to be 64. And then 2 to the 6th is going to be 128. So if we have that right, our answer is going to be in between 2 to the 5th and 2 to the 6th. So I'm going to go ahead and use this one. So I'm going to go for log 2 to the 6. And then this exponent is going to come down here as a coefficient. It's going to be multiplied by 3k. And then this crosses out to be 1 now. So my maximum data rate is going to be 6 times 3, 18 kilobits per second. And that was it for Shannon. Now for Nyquist, they're telling us that they're not specifically telling us to use Nyquist's formula. They're just saying that we have now a noiseless channel. And for that noiseless channel, we're going to be using Nyquist, and we're going to go ahead and assign V to V4, because it says right here that we have 4 level digital signals. So we have 4. And so for H is our frequency again, and that's going to be our range, which goes from 7 megahertz to 1 megahertz. So it's going to be 7 megahertz minus 1 megahertz. So H came out to be 6 megahertz, right? And so after that, we're gonna go ahead and just plug in stuff in our formula. It's pretty straightforward. So just MDR, maximum data rate, equals right 4 megahertz, which is our H, and the formula. So 2 times H, 2 times our H, which is 6 megahertz, and then times log base 2 of 4, right? And we know that 4 is 2 to the 2, so we were going to rewrite this as 6 megahertz times log base 2 of 2 to the 2, right? This is going to go away. This exponent is going to jump up in the front as a coefficient, again, using our properties of logarithms. 6 megahertz. Okay, and this is also a data rate, so bits per second, and then from there we're just gonna do 2 times 2, 4 times 6 is 24. I don't have the units in here anymore. That wasn't pretty smart, but there you go. So 24 megabits per second, right? So maximum data rate for our noiseless channel, this is our answer. And for Shannon, that was our answer. So just as a recap, when we're giving a problem, we just have to double check what they're asking for. So right away, I knew that I had to go ahead and calculate Nyquist as a noiseless channel. And the previous information that was given to me was to calculate Shannon's maximum data rate. So basically, noiseless channel, and that will be for this. Okay, so alright, and that was it. These are my results. Thank you.